Thank you for coming to our next session, Enabling Data and AI in a Regulated World. I will now pass it over to your presenters, Matthew and Alex.
Awesome. All right, can folks hear me okay? Excellent. We've got a small group, so we can make it a nice, intimate conversation. If you want to interrupt throughout, I'll repeat the questions because otherwise, your voices won't be heard on the recording. But yeah, this will be fun. So my name is Alex. I'm a product manager at Databricks. I'm joined by Matt, who's a cloud security architect at IQVIA. We're going to talk about enabling data and AI in a regulated world. Specifically, we're going to cover how IQVIA actually walked the serverless walk. It's one thing for us to go build these features. It's another thing for you to productionize them. IQVIA has done it. They're going to talk about how they did it. Then we'll talk about what has Databricks actually done to make serverless enterprise ready and how we're not stopping there, how we're continuously innovating the platform. You saw a bunch of exciting announcements at the keynotes yesterday and today. What are we doing to make sure that the platform keeps up with all of the continuous innovation that's ongoing? A few words about IQVIA first before I pass it over to Matt. So they are the human data science company. Of course, they're a regulated organization, so the strictest sort of compliance security requirements apply to them. They have a huge global footprint, 88,000 employees across 100 different countries or 100 and more different countries, and they're heavily relying on Databricks. So with that, I'll pass it over to Matt to talk about their journey to serverless, and then...
Thanks, Alex. So let's level set. Before we get into talking about a journey into something that you're going to embark on, you should know what you're talking about. And so serverless, let's talk a little bit about what it is to level set. This reference diagram that I'm going to progress through here in the next few slides is going to show up throughout the session. So some key points here on the left-hand side is the Databricks serverless network. The important takeaway is this is an external network to your infrastructure. In the classic or traditional computing paradigm, that is VNet injected, resides in subnets in your extended cloud. That's not what we're showing here. In this paradigm, you have on the left side an unallocated pool of available resources that just in time are made available to you and allocated to your customer-specific network. All right. So what can you do? You can run your notebooks. You can run your jobs. You can run SQL. You can do model serving endpoints. So a lot of what you do today in the classic. The two things we're going to highlight in this presentation is largely around the network policy and the network connectivity. Just to zero in on that fact, as you can see here, we have some areas of the expanded region now in green, some in red. The red, this would be things that you don't want to have access to from your serverless network. And that in green is what you're trying to connect, what you need to probably do your job, okay? In this case, you see it's emanating out of the network policies because in essence, the network policies act as your firewall rules, all right? So this is your allow list, your deny list. And in IQVIA's case, we operate primarily in AWS and in Azure. Sandwiched between those, what I've done is I've abstracted some of the common services that you will use when you're running in the serverless environment. You have your S3 or ADLS, that's your storage. And then the second over is relational databases or any managed service tier offering in the cloud space. Then you have the hosted option, the EC2 or virtual machines. And last is the network load balancer or standard load balancer, depending on the flavor of your cloud. So these are, now we have kind of both the subject, the predicate. We know, let's put them together. Well, you're going to do that via the network connectivity, all right? Kind of makes sense, connection, right? So Emanating from them are what it is that you want to connect to. So that's the frame of reference for much of what we're going to cover. All right, so let's talk about our journey. It started in November of 22, very early in the life cycle, even from Databricks' side with serverless. This was more of an evaluation period for us, and we quickly realized there were some features that we needed that weren't yet there in our highly regulated space to take advantage of this. You can see some of them leading up to August, where we actually did our POC in both clouds. In May, they private previewed the private link, and that was one of the linchpins that kept us from being able to actually utilize it. In Azure's networking, what that does is it allows you to route via DNS through your network, through a network interface that's on your extended cloud, so that traffic routes through that channel instead of going through the public channel or even over the cloud backbone, which for our purposes is our preferred posture from a security standpoint. But the other thing that was missing was really a better way to manage this aspect called an NCC, or network connection config. And we're going to touch more about that. In fact, all these things that I'm showing you that are bolded, we will drill into. Even at that point, we had to be selective in rolling it out, largely because there is a default of 10 NCCs per region, and that was not going to scale well for our organization, especially because we work, our preference is to keep things more isolated, and thus there's a limitation to the amount of sharing that we can do with the NCCs. We don't want to connect all of the storage that we ever expect to be using in the region all at once, and share that out to all the workspaces that we plan to use serverless on. So you can see in 24 in September, I met Alex, and I knocked on his door proverbially and begged for him to exchange or change that limit from 10 to 50. The reason that we were able to do that was that the default relationship was 10 NCCs to 50 workspaces, meaning for each NCC you can connect 50 workspaces to it. We just swapped those over, and the rest is history. And we were successful in being able to use it throughout the rest of, up until today. And we've helped pilot in private preview some of these things, such as stable IPs and private link service. We're currently in flight with the network policy, and we'll get into all of these coming soon. All right, I don't know where you guys are in your serverless journey, but if you're considering it, I wanted to kind of give you some lessons learned and some pointers in talking through InfoSec. But let's talk a little bit about the advantages, because usually you want to know why it is you want to use this, right? There are a lot more that could be done here. These are not exhaustive by any means, but these are the ones that I wanted to highlight for the purposes of our talk. A lot of times, if in the classic compute model, what you have to do is decide ahead of time on what your CIDR range is going to look like, how many nodes you can actually have running on your network. And if you have a lot of workspaces that you instantiate, you're making a lot of requests, knocking on the door for your cloud service department, you're begging for more CIDR ranges, right? And they kind of look at you and say, boy, you're greedy. You're asking a lot. These don't grow, on trees or something. We have a certain amount of these. Maybe you don't have that concern, and you can expand at will with them, but it's a concern for us. And one of the advantages that serverless offers is the ability to scale beyond what your initial footprint is. So this is useful also because you may not want to provision 256 nodes just so you can handle the ramp up that you need to train your model, but most of the time you were able to do all your work on 16. So this allows you to scale up just in time for those workloads and not have to have your subnet ranges for your host and your compute subnets tied up or just sitting there empty. So the second point here that I'll make was one that we didn't anticipate ahead of time, but we've seen this in practice, and that is it's very helpful for POCs. If you want to spin up a workspace and you're doing experimentation, you don't know or don't have to agree ahead of time on how many IPs to request. You can get by with far less, in fact, if you're using serverless to do your work. And depending on your workload, there may be considerable cost savings. This ties in with point 4, which is you're not having to worry about the spin up or the wait time. That could be several minutes. We've experienced that, right? I'm wondering if they should release like the dinosaur game when you lose your internet connection, so you can actually do something while you're waiting for it to spin up. But in all seriousness, the serverless experience bypasses all of that because of the unallocated pool that's already there, ready at your disposal to be provisioned when you need it. There's still a few seconds. It's not like right there, but it's far better. So with those as sort of the technical advantages, why you would want to use it, there are more. Let's consider how do we talk to InfoSec? Well, InfoSec's realm is data security primarily, and there is a principle called the CIA triad, which applies to the context of data: confidentiality, integrity, and availability. Confidentiality is largely around making sure that the data gets to the intended recipients and only the intended recipients. Integrity is more about that process. Can I have insights to know that the data is reaching the intended persons and there is nothing else disrupting the pipeline? So being able to monitor and log the access, see the access logs. Also, availability. So this is making sure that the data lands where the person needs it, when they need it, and where they need it. All right, so some of the pointers, and I've tied them into the CIA paradigm that we just talked about to consider. Bring up the fact that there are several layers of isolation embodied in the context of these serverless resources. That's not unique to serverless. However, there are differences that matter with respect to the two outermost, the compute and network, and we'll talk about those a little bit. But starting in the center, the container, it runs in an unprivileged manner, so you're not worried about it jailbreaking and impacting. They're going to have root access or something like that. All right. The disks, they're encrypted at rest, and I'll just bring it up here, though it doesn't relate to the disk. There's also encryption in transit, so when the data is moving, and they are using TLS 1.2 and above. So that's checking off the box on those two layers. On the compute, we will drill into that in the second point in a second, but let's talk a little bit about the network for a moment, because what's important to note is that those compute resources that get allocated to you when you want them, well, they're isolated at the network level too. And that isolation doesn't just prevent your workload from being seen or interacting with another unrelated account that happens to be also using serverless, but even workloads within your own account, or even each workload stands alone, is an island to itself, and that is how it's designed. So that isolation is key. Drilling into the compute for a moment, one of the things that they're going to want, that your InfoSec department will want to know, is what happens to these VMs when they're deprovisioned, when you're no longer using them. Well, the answer is they are wiped, they're ephemeral, and there's not going to be any concern of the data being exfiltrated or made available to someone who subsequently were to use the VM in the pool later. So, also I have in here, and this is taken from a lot of the security documentation about serverless. There's hardening that's applied to the environment, vulnerability scans running. So these are all important things that InfoSec is going to want to understand. To the integrity aspect, audit logs are in parity with that you will have that you have today with classic compute. So you're going to be able to trace and understand what the user is doing in your serverless, just as you are able to see what they're doing in your classic compute. All right, we've talked about isolation of all the parts the anatomy that make up and comprise the serverless, but what about protecting the edge? We haven't talked much about that. Yes, we talked about that they are an island to themselves, but that wouldn't really work in principle because you have to connect to something to run and process your data with. So there's got to be a way to allow something in, right? And we talked about that a little bit, but this was patient 0 for us on the slide here in that blue area with the storage. We did our POCs on S3 and on ADLS, and we used private endpoints on the Azure side to complete that. And then at the time on AWS, we fell back to using a gateway endpoint or an interface endpoint. And the difference there is that's using the cloud backbone to arrive at it, so it's not a public channel, but it isn't on par with an actual local call like it would be in the private endpoint. Today on AWS, you can do exactly the same as you would in Azure. But I wanted to show you, in case you didn't want to go through that, on the AWS side, you could use a bucket policy to further restrict it. In this case, I've highlighted in what our policies are some of the actions that we are using, and more importantly, the condition we have against the principal tag identifying our Databricks account GUID, and that's how we're ensuring that we only allow traffic in for our Databricks our Databricks account instance. So it provides a little more security than just opening it up network-wise. It's actually checking to see who are you. And again, there's far more to cover here. I have the URL here to the Trust Center. I'd encourage you to check that out. That will aid you with your conversations. So let's talk about governance and actually executing this. How do you administer this at scale? So the network connection configuration, that is a mouthful to say every time. These are account level objects that require elevated permissions to configure and attach to your workspaces. What that means is you don't want to give that to everyone, right? Account admin should not be something that you require to have access to spin up your resources or to work with your workspaces. That's just not a good design paradigm. So you're going to need to have a way to administer them. But these NCCs exist as an abstraction that can apply to more than one workspace. We kind of covered that before when I said that there was this 10 region limit, and there was also a 50 limit to your workspaces that could associate with a single NCC. What the NCC is going to govern, it can be broken down into 2 points covered by these topmost bullets: your source and your destination. The stable IPs are going to help you to identify the source of incoming requests from the IPs from your serverless network that you will then use to create firewall ACLs against on those resources that you want to connect to. And the other side of that is the private endpoints. Those are the destinations that you want to reach into from your serverless resources. So that's the balance there. And what is pictured on the right is a description. It's not prescriptive. We're not exactly adhering to this. This is a simplification of how you might roll out your NCCs. I think one of the things that you'll note right away is there's a delineation between the dev on the green at the top and the purple being prod. So one way to describe this or think of this is you can share your NCCs and differentiate them or stratify them by your deployment stages. That's just one way you might choose to operate these. Your mileage will vary dependent on how your business operates. Okay, there is a UI for this, but I would encourage you not to fall back to the UI to do this at scale. Use the REST API. One of the main reasons for that is the UI there's all this context switching you'll have to do if you're trying to identify what NCC applies to what workspaces, and that will get old very quickly, and you may not catch it all. So using a programmatic approach makes it much easier for you to manage, and you don't have to do this from scratch yourself. This QR code, some of you are just very trusting and you just go ahead and scan QR codes and you don't know what you're actually doing. This one will get you to a Git repo that has a Python wrapper around the REST API. It's a client interface to help you manage your NCCs. I highly recommend it. I use it all the time. You need to have a governance plan. You need to agree on a few important things, such as who is allowed to make a request. And you'll need to identify, at least at a minimum, things like what is the workspace by ID or name that you want to connect with an NCC on, and what is the storage account by ARN or resource ID, depending on your environment, that you want to allow access. Again, this is descriptive. You will need to develop one for your space. That makes sense. And lastly, I have found it very helpful because of that context switching aspect to log these and catalog them in a semi-structured file like a JSON. And this is basically what I use today to help manage and understand at a product level what are the NCCs that they are using with their various workspaces. And it helps me to identify where there's a potential area where I can collapse certain things so that we can reuse NCCs. So let's talk a little bit about some use cases in the field. So one example I have to share is with serverless stable IPs. We use this to do a cross-cloud accessibility of a lakehouse federated query. In this case, we had a SQL server that was hosted in AWS, and we had our Databricks instance in Azure. And we wanted to, and it was serverless. And we wanted to be able to reach in and query from the SQL server in AWS. So stable IPs to the rescue. We were able to leverage the stable IPs to whitelist the outbound IPs and create an ACL exception so that that connection could be established. Our second use case here involves private endpoint access to internally hosted services in the same cloud. In this case, slightly different. Both are in Azure. We're trying to do a federated query, this time to a SQL server that's hosted on a VM that we manage, not a managed service offering in this case. There's a little more plumbing involved to do this, but what we were able to do is use a standard load balancer with a backend pool that pointed to the VM hosting that SQL server and attach a private link service to that, and the connection was successful. The third use case that we will talk a little bit about is the serverless policies. If you're using serverless today, you're in a situation like us where you need to have you're going to need to manage the process of rolling out your enterprise policy. Otherwise, you can do this from the ground up on day one. In our regulated industry, our default policy is a deny all stance. So what that means is if we just turn this on today, we kill a bunch of things that probably not, we're going to hear about that. So they offer a dry run or passive mode where we can ensure that there's time for our users to identify and then create exceptions to allow specific connections to be made against their serverless. So you'll need to work out what that process looks like in your enterprise. And then this one is near and dear to me because I think I lost a few hairs on my head with this exercise. In Azure, if you haven't encountered this and you're using private endpoints, you will. And bottom line is this condition applies where you have a private DNS zone with the same type as the resource that you're trying to access. So in our example, we had a customer that we were delta sharing the data with, and they were using both a serverless and a classic compute to perform operations against the data set. They were successful with the private endpoint in the serverless environment, but they couldn't complete the request when trying to do it with a service endpoint in the classic. And the reason for this is this limitation with the architecture of Azure's private DNS and how they route the private endpoints. If you have the same type, in this case DFS, already listed in your private DNS zone, and there's at least one private endpoint connecting to that storage already, which they actually did it to themselves in this case by doing it in the serverless, then guess what? Your environment is going to be expecting you to have a private endpoint. So you're going to end up with a scenario like what we had here, where you're under the auspice of a private DNS zone. You get this nasty unknown host exception, could not find or resolve. And if this is, we use the NS lookup debug against the storage account to identify that, yep, I get this NX domain, it's not found. I don't know where to route. If you do that same thing from an environment that doesn't have a private DNS zone, though, you will be able to find the public domain name, which is what's over there on the right in that red box for you. And what we were able to do is, working with the customer, we added a canonical name reference that pointed back to that public name, and that allowed it to complete the request over the service endpoint instead of trying to use a private endpoint. There is an alternative to this. where you can enable the fallback on the virtual network link in your private DNS zone. And what that does is it sets a resolution policy such that when that request is made, your private DNS zone will do an NX domain redirect, and then it will fall over to the public one, just like it did here. So that would be another option here. I wanted to leave you with this slide to share with you that we are using serverless and have adopted it in many use cases. We're using all 4 flavors, and we have over 174 workspaces that are currently using it. And the trending line is in the upward direction. We're running it in 5 different countries, 6 regions, and across 2 clouds. This is what I would bring as some proof to the availability and that it's ready for production workloads. So with that, I'll turn it over to Alex, and he's going to share with you future roadmap.
Cool. Thanks, Matt. So it's one thing to build these things, but it's awesome to actually see how our customers implement them, the problems they run into. So this was a lot of fun for me to learn about as well. So I wanted to talk about, is this real or not, and where are we going next? This is from last year. When I stood on stage like a year ago, exactly this was the slide that I shared that actually covers the features that Matt had talked about. The first one is about firewalling access to your various storage accounts and other cloud resources. The second one is about egress controls to prevent data exfil, right? That network policy where you say, deny all by default, but allow these certain destinations. And the third one is about private connectivity. Like, great, I denied all by default, but how do I actually connect privately to the resources that I need to connect to? When we shared this last year, this was where we were. It was, like we had some stuff available on serverless, but you'll notice we had to go use case by use case. We had these features shipped for data warehousing, for data engineering, for Mosaic AI scenarios in different stages. What we've been working on is kind of 2-dimensional, right? One is consolidate all of that. So this is the view as it is today. There's no more data engineering versus data science versus Mosaic AI. We build these features now once on the platform, and they're available for whatever new feature it becomes a part of Databricks. The other thing is, of course, we've been working on filling out the green checkboxes. So we're practically there. Matt talked a lot about Azure. We're there on AWS and Azure. On GCP, we're practically there. Like almost everything is available. We're just finishing up some of the work around Private Link, or as they call it, Private Service Connect. So if you have any GCP scenarios, happy to talk to you about that. But we're not done, right? Like as soon as we check this green box, I'm not going on vacation. There's plenty more to do. The thing that I did was I talked to Matt while we were making this session, and I asked him, hey, what are your continuing pain points in serverless? Like once we fill this out, what's still keeping you up at night when it comes to platform security and connectivity? And we kind of narrowed it down to 3 things. So there were 3 serverless asks. There were actually a couple more, but these were like the 3 most interesting ones I thought we could talk about. The first one is, hey, this NCC thing is cool, but it works really well for my scenarios where I need to, like my organization, to access my things over private link or using these firewalls. But what about in these delta sharing scenarios? There's so many different data sharing scenarios on the platform. Connectivity there is kind of clunky. Are you doing something about that? The second thing that Matt brought up is, hey, there's an increasing number of scenarios where I have my workspace, it's in some home region, but the compute for a number of different reasons is actually in a different region, or maybe even one day in a different cloud. These policies, everything I'm building, right, they apply to stuff in my home region. How do I extend it to apply to compute anywhere? And the third one was, hey, in Classic, we could peer networks or use some type of gateway to actually just create this hub and spoke model and get to our on-prem resources. In serverless, on-prem is a little bit more clunky. How do we do it at scale? So the good news, like I was smiling ear to ear while Matt was telling me these things because we're working on all 3 of them. So I'll go a little bit deeper on each one of these, and that'll kind of conclude the talk, and then happy to talk to you more about dates and things like that. So going a little bit deeper on the data sharing scenario. First, if you're a provider and a recipient of the data, both kind of have a little bit of a management problem, right? If you're a provider and you need to allow list recipient 1, 2, 3, 4, 5 to access your storage account, you have to go to your cloud administrator and say, hey, could you allow this IP, and then come back the next day, can you allow this IP, and then come back, like on and on and on. If you're a recipient, same thing, right? If you're getting shares of more than one storage account every single time, you're like, hey, can you open up access so that I can access storage account 1 versus 2 versus 3? You don't want to involve those administrators. You don't want to run back and forth with them constantly. So the solution that we're building now, not available yet, this is like the exciting roadmap stuff, is each of them will do it exactly once, right? So this NCC object is now also going to be available on the Metastore itself. So a provider can just say, hey, I want this private endpoint deployed on my storage account, and all recipients that I share with, I want them to just use that private endpoint to access this data. Same thing for the recipient, right? They will allow access on this new object that we're shipping inside of Databricks once, this policy evaluator that's in green, and now they can access any of the storage accounts behind that share. So super excited about that, because I think it's just gonna make this so much more simple and make Delta sharing and clean room scenarios much, much easier to administer. The second thing I mentioned, you have your home workspace region, compute can be somewhere else. The prototypical scenario for that is GPUs, right? These are like very expensive, scarce resources. We might serve you GPUs from a different region. You still want your stuff to just work, right? If you've created a private endpoint to a storage account that's otherwise inaccessible, and your GPUs in a different region today just won't be able to access that storage account, that shouldn't be something you have to think about, right? This should just implicitly work for you. So that's where we're working on, is kind of building that green line. Doesn't do it kind of the justice of what this is, but we're building this entire infrastructure that will interconnect our regions so that, regardless of where the GPUs are being served for, starting cross-region, eventually cross-cloud, your NCCs, your network policies, everything will just seamlessly work. And then the final thing, this one's the nearest and dearest to my heart at the moment. We've had lots of customers. Matt talked about the scenario where he needed to access a SQL server that is sitting inside of his VNet in Azure. And he deployed a load balancer in front of that SQL server with this thing called private link service, and he was able to establish connectivity. We've heard feedback from customers that, yeah, that works for like 1, 2, 3, 4, 5 resources. I have 100 VPC resources, or I have like a whole on-prem network that I need to get access to. Can you help me do it at scale? So this is the kind of the model today, right? Is you're creating individual connections. The thing that we're working on is a fat pipe, right? Basically, this gateway, if you will, that connects your serverless. It's dedicated to you, to your existing VNet or VPC if you're on AWS or GCP, that then can just pick up all the routing rules to get you to the resources that you define access to, or even all the way through to on-prem via transitivity. So that one, I've gotten a lot of feedback from customers on during this DAIS. If it's a scenario that's interesting to you, super happy to talk to you about what we're doing there in more detail. So that's kind of it for us. Just a recap and takeaways. We brought up 3 things during the agenda. So like the most important takeaways for this thing are, serverless is battle tested. IQVIA has done it. It took them a few years because they were pioneering everything. Their crawling meant you can now run, right? So you should be able to do this on the order of months and hopefully use those tips and tricks to get past your InfoSec teams. Serverless is enterprise ready. We've platformized all of these features so they just work regardless of what you're using on the Databricks platform. You just need a game plan to execute. And then finally, we're going to continue to partner with you. We're not done. Plenty more to do. So again, looking forward to your feedback and helping us build the next great thing. And yeah, with that, happy to answer questions. We can take them live or we can do them one-on-one, whatever's simpler for everybody. Thank you.